Example of steady state processes, nozzles. A nozzle is a steady state device whose purpose is to create a high velocity fluid stream at the expense of the fluid's pressure. It is contoured in an appropriate manner to expand a flowing flow smoothly to a lower pressure. Contoured in an appropriate manner to expand a flowing flow smoothly to a lower pressure. Thereby increasing in velocity. There is no means to do any work. There are no moving parts. There is no means to do any work, and there is no moving parts. W equals to 0. There is little or no change in potential energy and usually little or no heat transfer. Negligible potential energy, and also there is flow heat transfer for a steady state nozzle. An exception is the large nozzle on a liquid propellant rocket, such as was described in the section 1.7, chapter 1, as an example, in which the cold propellant is commonly circulated around the outside of the nozzle valves before going to the combustion chamber, in order to keep the nozzle from melting. In this case, a nozzle with significant heat transfer in the exception and would be noted in such an application. In addition, the kinetic energy of the fluid at the nozzle inlet is usually small and would be negligible if the value is not known. So, kinetic energy at intrust flow can be negligible if there is no information data on the velocity inlet. So we can write the steady state first law which is Q plus delta car E, for example. Let me write the velocity term. And the inlet we can already there is no work and heat transfer. So we have this relation. For the steady state nozzle. This is the end of this section. The next section is about diffusers, and for diffuser we have same relations. And a steady state diffuser is a device constructed to decrease a high velocity fluid in a manner that results in an increase in pressure. Is a device constructed to decelerate a high velocity high velocity fluid in a manner that results in an increase in pressure. In essence, it is the exact opposite of a nozzle. And it may be thought as of a fluid flowing in the opposite direction through a nozzle with the opposite effects. The assumptions are similar to those for a nozzle, and we can also use this relation for a steady state diffuser. The next section is throttle in the next video part.